LeetCode number 1510, Stone Game 4. So for this problem we have Alice and Bob taking turns removing a square number of stones from a pile of stones, right? So we're given the amount of stones that are in the pile, and then Alice and Bob take turns removing square number of stones from that stone pile. And you lose the game when you cannot make a move. So there are 0 stones in the pile, okay? So yeah, we just need to return true if Alice wins the game with the given amount of stones in the pile at the beginning. And keep in mind that Alice is the player starting. Okay, so for this problem, it's pretty easy to see that it is a recursive problem. And of course, you can make it into a dynamic programming solution. So we'll do straight that. We'll do, first of all, the recursive solution, and then we'll convert that to a dynamic programming. So the first thing that you want to do is you want to use a for loop that goes through all of the square numbers up to the current number. So of course you can't remove more stones than the stones that are in a pile. So we want to stop this for loop. This for loop will go through all of these squares up to the number of stones in the pile currently, because we can't remove more stones that there are in the pile. So we're going to start from 1. We can't remove 0 stones, so we're going to start from 1, go up to the square root of this, of 10 to the power of 5. And this is actually not completely necessary, but I've put that here just to show that this is not an infinite loop. And then what we do is we take the current square is im times I, so this will go through all of these squares. And we check if it is greater than the amount of stones that we have in our pile, and if it is, then we can stop already, right? So this is why I was saying that this is actually not necessary, because you already have that break here. But anyways, this doesn't really matter. So what you want to know now is if I removed this amount of stones from the pile, so this is the current amount of stones, this is the amount of stones that is a square number that I can remove from the stone pile. Now, what you want to know is, would my opponent be able to win if I give him this amount of stones? And if he can't, then it means that by doing this move, you essentially win the game, right? So you can see that it is a recursive nature here. So what I'm going to have to say is, if my opponent cannot win this game when I give him the remaining amount of stones after removing the current square number of stones, then it means that I can win the game because he cannot, so I will be the one winning. And so I can return true, right? But if we never enter in this condition, meaning that we never find a square number that makes this condition true, so all of the square numbers that we try do not let us go into this condition, so there's always one way for the opponent to win, then we're going to have to return false, right? So if we never have squares that will make us win, we need to return false. If we have at least one, like the first square that we find that makes so that the opponent cannot win, we can return true. So this would be the naive recursive solution. But now you can notice that we are making a lot of possibly repeated calculations. So for example, we could calculate the result for n equals 100, and then maybe we can calculate again later on in a different recursion tree. So what you want to do is you want to memorize in a cache or in a memo the results, because we have only one parameter, and when you call the function with the same parameter, the result is going to be the same. So you can just store it so that you can later on return it, right? So we're going to do that. So we're going to initialize a cache that keeps track of the answer for any given n as an input. And then what we do is we check if we have a definition of the answer for the current input parameter. So looking up the current input parameter in the cache doesn't give you undefined. So remember, if it gives you undefined, it means that it has never been assigned. But if it is not undefined, then it is either true or false, and so we can return that result. And now you just need to remember to actually do the assignment, or this will always be undefined. So whenever we return an answer, we want to actually store that answer in the cache. And so we can do that by assigning, like this, every time we do a return. So yeah, that's it. I'm going to submit the solution to show you that it works. And remember that this assignment expression, you can return the assignment expression because the assignment returns the value that is being assigned itself. Okay, so you can do that in one line like this, without having to maybe store the answer and then assign it to the cache and then returning. Okay, so that's it for me. Thank you for watching, and bye.